Probabilistic Systems Analysis. Homework help. For any help regarding probabilistic systems analysis homework help visit https://www.statisticshomeworkhelper.com, email info@statisticshomeworkhelper.com, or call us at +1 678 648 4277 statisticshomeworkhelper.com. 1. Professor may be right often has her science facts wrong, and answers each of her students' questions incorrectly with probability 1/4, independently of other questions. In each lecture Professor Wright is asked either one or two questions with equal probability. A. What is the probability that Professor Wright gives wrong answers to all the questions she gets in a given lecture? B. Given that Professor Wright gave wrong answers to all the questions she was asked in a given lecture, what is the probability that she got 2 questions? C. Let X and Y be the number of questions asked and the number of questions answered correctly in a lecture, respectively. What are the mean and variance of X and the mean and the variance of Y? D. Give a neatly labeled sketch of the joint PMFP X, Y, X, Y. Problem. E. Let Z equals X plus 2Y. What are the expectation and variance of Z? For the remaining parts of this problem, assume that Professor Wright has 20 lectures each semester, and each lecture is independent of any other lecture. F. The university where Professor Wright works has a peculiar compensation plan. For each lecture, she gets paid a base salary of $1,000 plus $40 for each question she answers, and an additional $80 for each of these she answers correctly. In terms of random variable Z, she gets paid $1,000 plus $40 Z per lecture. What are the expected value and variance of her semesterly salary? G. Determined to improve her reputation, Professor Wright decides to teach an additional 20-lecture class in her specialty, math, where she answers questions incorrectly with probability 1/10 rather than 1/4. What is the expected number of questions that she will answer wrong in a randomly chosen lecture, math or science? statisticshomeworkhelper.com. Here, C is some constant. What is EXY3? Hint, this question admits a short answer/explanation. Don't spend time doing calculations. 3. Joe Lucky plays the lottery on any given week with probability P, independently of whether he played on any other week. Each time he plays, he has a probability Q of winning, again independently of everything else. During a fixed time period of n weeks, let X be the number of weeks that he played the lottery, and Y the number of weeks that he won. A. What is the probability that he played the lottery any particular week, given that he did not win anything that week? B. Find the conditional PMFPY, X, Y, X. 1. The joint PMF of discrete random variables X and Y is given by C. Find the joint PMFPX, Y, X, Y. D. Find the marginal PMFPY, Y. Hint, one possibility is to start with the answer to part C, but the algebra can be messy. But if you think intuitively about the procedure that generates Y, you may be able to guess the answer. E. Find the conditional PMFPX, Y, X, Y. Do this algebraically using previous answers. F. Rederive the answer to part E by thinking as follows. For each one of the n-y weeks that he did not win, the answer to part A should tell you something. In all parts of this problem, make sure to indicate the range of values for which your PMF formula applies. For let X and Y be independent random variables that take values in the set 1, 2, 3. Let V equals 2X plus 2Y and W equals X minus Y. A. Assume that P, X equals K, and P, Y equals K, are positive for any K, 1, 2, 3. Can V and W be independent? Explain. No calculations needed. statisticshomeworkhelper.com. For the remaining parts of this problem, assume that X and Y are uniformly distributed on 1, 2, 3. B. Find and plot PV, V. Also, determine E, V, and var, V. C. Find and show in a diagram PV, W, V, W. D. Find E, V, W greater than 0. E. Find the conditional variance of W given the event, V equals 8. F. Find and plot the conditional PMF PX, V, X, V for all values. 5. Suppose the waiting time until the next bus at a particular bus stop is exponentially dis-1 tribute, with parameter lambda equals 1. Suppose that a bus pulls out just as you arrive at the stop. Find the probability that A. You wait more than 15 minutes for a bus. B. You wait between 15 and 30 minutes for a bus. G1. Clark is a news reporter who lives in Metropolis. Every morning he drives from his apartment at point A to the Daily Planet office at point B for work. He travels only in the north and east directions, and he chooses each path with equal probability. The heavy line in the diagram indicates one such valid path. StatisticsHomeworkHelper.com. A. Determine the probability that the path in the diagram is the one he actually picked this morning. B. There is a phone booth at point C, the intersection of 4th Street and 3rd Avenue. Find the probability that he drove past this phone booth on his way to work this morning. C. Find the probability that he drove past the phone booth, given that he was seen on the portion of 3rd St. between 2nd and 3rd Avenue, point D. D. Repeat part B. For the general case where his apartment is located at the intersection of Main and Broadway, the Daily Planet is located at the intersection of WTH Street and Heath Ave, and the phone booth is located at the intersection of XTH Street and Youth Ave. Assume the same numbering scheme for the streets. Note that this problem is of interest only if X less than or equal to W and Y less than or equal to H. Does your answer make sense for the special cases? I.W equals 0, i.e., the office is on Main Street, and 2.H equals 0, i.e., the office is on Broadway? Broadway? StatisticsHomeworkHelper.com. 1a. Use the total probability theorem by conditioning on the number of questions that Professor Wright has to answer. Let A be the event that she gives all wrong answers in a given lecture, let B1 be the event that she gets one question in a given lecture, and let B2 be the event that she gets 2 questions in a given lecture. Then, PA equals PA, B1, P, B1, plus PA, B2, P, B2. From the problem statement, she is equally likely to get 1 or 2 questions in a given 2-4 lecture, so P, B1, equals P, B2, equals 1. Also, from the problem statement, PA, B1, equals 1. And for 16 because of independence, PA, B2 equals 1, 2 equals 1. Thus we have B. Let events A and B be defined as in the previous part. Using Bayes' rule. Solution. B. Let events A and B2 be defined as in the previous part. Using Bayes' rule. P, B2, A equals PA, B2, P, B2, PA. From the previous part, we said P, B2, equals 1, PA, B2, equals 1, and PA equals 5. Thus 2, 16, 32, 1, 1, 5, 3, 2, 1, 5 P, B2, A, equals 16, 2 equals. As one would expect, given that Professor Wright answers all the questions in a given lecture, it's more likely that she got only 1 question rather than 2. C. We start by finding the PMFs for X and Y. The PMF PX, X, is given from the problem statement, statisticshomeworkhelper.com. She answers the first question correctly, or she answers the second question correctly. Thus, overall, the PMF for Y can be found by conditioning on X for each value that Y can take on. Because Professor Wright can be asked at most 2 questions in any lecture, the range of Y is from 0 to 2. Looking at each possible value of Y, we find. Note that when calculating P, Y equals 1, X equals 2, we got 2, 3, 1 because there are 2 ways 4 for Professor Wright to answer one question right when she's asked 2 questions. Either she answers the first question correctly or she answers the second question correctly.